Okay, so optimization is referring to the process of finding values that produce a desired max or minimum. So when you optimize something, it's finding max and min. Things are not changing, so this is not similar to related rates at all. If we look at a graph, and I know my graph got cut off, but we'll just add this in. So a max is a high or a low point. So what we'll notice is at the maximum of this graph, it occurs when x equals little a. And that, if we look at these blue lines, they drew our tangent lines, which is the derivative. So what I notice here is that my derivative is positive because it has a positive slope. And then my derivative is negative because that's a negative slope. But at that value, there's actually a horizontal tangent line. So my derivative is equal to 0, okay? So I know that my derivative equals 0. And our derivative goes from positive to negative. So positive to negative derivative, okay? The minimum is this low point, which is at x equals b. Same idea, I would have a horizontal tangent line there as well. And our derivative goes from negative to positive. So derivative goes from negative to positive, okay? And that's going to be a rule that we will use again pretty soon when we do function analysis. So in order to find where a max or a min might occur, you've got these 4 steps. You need to either use the original function or create one because they might vary it slightly. Take the derivative, solve for all the values, and then check values in the original equation to figure out if it was a max or a min. Typically, when you solve, you only get one answer, so it's going to be pretty obvious, okay? Now, because we're doing applications, there are time intervals that might be a restraint. Usually 0 is a common restraint, and they might not always specify that. So if you have endpoints or if it's on an interval, you want to use those as well. Some terms that might get used are relative or local. Relative, local, they mean the same thing, max or min. That just means in a small window, that's the highest or lowest point. So you'll notice like right here is a relative or local max, relative or local max. And then same thing for min. Relative min, relative min, relative min. Endpoints count. The word absolute or global, that's a B, sorry, can mean the overall highest or lowest. So there's only one of those, okay, unless there's a tie. All right, so let's try some problems. Typically when you want the max or the min, they'll specify it, but you'll be able to tell you want the y value of the original function. If you want to know when it occurs, then you want the x value. So just look at the wording. If we look at number 1, they give us a function and it just says what's the greatest possible value. So I'm looking for a max of this equation. I'm going to rewrite it as powers. Okay, so if we want to find the max or min, we're going to find our derivative, which is a power rule. So 2x to the negative 2/3, 1x to the negative 1/2. Okay, and then we want to set this equal to 0. So I'm going to write this a little nicer because I want to solve it. So you have some options. I can move it to one side, multiply because it's a ratio, but then I have to move them back anyway. So I'm going to get a common denominator. And this one's not super easy, so this is some good algebra review. So to get a common denominator, remember we just multiply by both on the bottom. So I'm going to multiply that on top and that over there. So we get 2x to the 1/2 minus 1x to the 2/3 all over, it would be this, x to the 2/3 times x to the 1/2. Okay, I'll just pause to let that sink in. Now, when you're solving, what I want to notice is if I plug in 0 on my denominator, that makes this undefined. So we want a little note to ourselves that we can't have 0. Then I can actually get rid of my denominator and just solve my numerator. Now, this one's a little tricky too. We want to common factor, and you always want to common factor the lowest exponent. So that's x to the 1/2. So if I take out x to the 1/2, I'm left with 2 minus, and when you take out a 1/2, you you really subtract it. So let's get a common denominator. 4, 6 minus 3, 6 means x to the 1, 6. Okay, so let's solve. So x to the 1/2 equals 0, or 2 minus x to the 1/6 equals 0. Well, square both sides, so x equals 0. We already know we had that restraint though, because it made our derivative undefined. Add, and then I'm going to apply the 6th power to both sides. So x equals 64. Now, that is the x value that would give us a max or min. Since we want to maximize this and there's no endpoints, that is going to be the x value that tells you when the max occurs. But we want to know the actual maximum value. So we're going to plug in 64. So 6 cubed root of 64 minus 2 root 64. Oh, the cubed root of 64 is 4. The square root of 64 is 8. So we get 24 minus 16, which gives us 8. Okay, lots of great algebra. All right, let's try a little application. So they tell us the speed through the Holland Tunnel in New York depends on the density of traffic. S is the speed. Okay, so they give us that equation. And D is the density. Okay, and it's vehicles per mile. So they gave us an equation right here for speed. So that's how speed and density are related. Find the speed that will maximize the flow. So we want to maximize flow, and they give us a hint because they just don't expect you to know how flow works. So flow equals speed times density. Well, I know that this equation is speed, so we do need to substitute that. So 52 minus d over 3 times another density. Okay, so I will distribute, because I know I'm going to have to find the derivative anyway, 52d, and then I'm going to write this as there's like a 1 there, so 1/3 d squared. I think that'll help when you go to find your derivative. So if I want to maximize, that means I want to take the derivative of flow. So d is your variable, so 52, and then minus a power rule, 2/3 d to the first. And we want to set that equal to 0. So I'm going to add 2/3 to the other side. And then multiply by the reciprocal. So 2 goes in there 26 times, so 26 times 3, 78. So D equals 78. So that's the density, okay? And they want to know, find the speed. So if that's my density, I know speed is equal to 52 minus density over 3. So 52 equals, minus 78 over 3. I keep writing equals. I don't know why. Sorry. 26. So 26. And it's in speed, so miles per hour makes sense. And I got I. Okay. I did get this question from a practice AP exam. So, all right, number 3 is a pretty typical problem because we want to maximize a rectangular area that creates 4 pins, not necessarily the same size. So see how we have 1, 2, 3, 4 pins. This is just a drawing. He has 800 feet of fencing and he doesn't need to fence along the barn. So all of these other spots are the fence that we need. So what is the largest area that he can enclose? So we want to maximize the area. So what we don't know is how long anything is. So I'm going to let this be X. So that means all of these are X. So we have to put fence here. And we're going to let this just be Y. Okay. So if I want my perimeter of my fence, I need to set up an equation because that's how we're going to use that 800. 800 of fencing is perimeter. So we've got add up all the sides together. Add up sides. So I get P equals 1, 2, 3, 4, 5x plus my 1y. We don't know if these are the same size or not. That's why they kind of drew it that way. So I can't have any more specific information. Our area, well, even if there's a fence there, our area is still length times width, okay? So our length is y, and our width is x. Okay, so this kind of follows some of the examples we saw in related rates because I have two relationships. Focus on what you want to maximize. We want to maximize area. So what we want to do is we want to solve perimeter to do a substitution into area. And you really get to pick. I know that my perimeter is 800. And I really can solve for x or y. It doesn't matter. I think it's easier to solve for y in this equation, so that's what I'm going to do. So 800 minus 5x. So then I can substitute that for y. So area equals 800 minus 5x times x. So distribute. Okay. And if we want to maximize it, now we can take the derivative. So a prime is equal to 800 minus 10x. And then we want to set that equal to 0. Add 10. I'll do it over here. 10x, sorry, and divide by 10. Okay, now we do have some constraints because obviously we can't use more than 800 feet of fencing. So what we really found is this is 80, 80, because we only have one value, so that's going to be the value that maximizes it. 80 and 80. If we used our endpoints, we wouldn't have an area, a region enclosed at all. So that doesn't really make any sense. So I need to find my length. So if I've got 80, 80, 80, 80, 80, so I know perimeter, x is 80. So 800, sorry, we could have used our drawing, but I'll just go ahead and use my equation, equals, what's that, 400 plus y, so y equals 400. So our area is 80 times 400, which is 32 with 1, 2, 3 zeros. What do we have? Feet? Yeah, feet squared. So guess what? It's D. All right. This is a pretty typical problem, and it does take some time. Number 4, I've also seen this on released exams on the multiple choice. So they give us a parabola shape because it has symmetry, so that's kind of nice. And then sometimes they have a rectangle, sometimes it's a square, this time it's a triangle. So it says a right triangle is inscribed under the curve. So this is 36 minus x squared. So we know that this is 36 just from our math knowledge. Our restraints, if we set this equal to 0 where it would cross the axis, I would have 36 equals x squared, x equals plus or minus 6. Okay, so that's as large as it can be. What is the largest area that's possible? So area equals 1/2 base times height. So the height of this triangle is going to be on our curve. So the height is actually the y value on the parabola. So height is this. Our base, well, we don't know what our base is going to be, so it's going to be dependent on this. Okay, so what we know is that this much of it is definitely 6 units long. If this is going to be my height, that means if I start at 0, I went over X amount. So our base is actually 6 plus some X amount. Because if my triangle is smaller, this makes